Now what if we had to graph something that's a little more intricate? For example, g of x equals -8 divided by x plus 3, and then all of that is being added by 2. Here's the first option. What we could do, if a function is in the form that you just saw, which you can see right here, we could draw the asymptotes, which are x equals h and y equals k. And then we plot points to both sides of those, to left side, right side, and then connect the two branches. And that's what we're going to do. Here is that function again, g of x equals -8 divided by the sum of x plus 3, and then plus 2 is being added to that fraction. Okay, first, I'm going to figure out what the h and the k values are. Based on what was written earlier, we know that h is -3 and k is 2. K would be this number here. All right, so therefore the vertical asymptote would be x equals h, so x equals -3, and the horizontal asymptote is y equals 2. All right. Here those are graphed, and I will just label the x and the y axis. We also could have determined the vertical asymptote by setting the denominator equal to 0. So x plus 3 equals 0, solving that, and we get x equals -3. So that would also give us the same asymptote. And since the asymptotes are related to the domain, we cannot substitute. The domain would be that x can't be -3. But I wrote in interval notation where we're excluding -3. And the range is that y cannot be equal to 2. Or you can write it this way in interval notation. Now we need to pick x values to the left and the right of the vertical asymptote. 5 would be a great number to pick, because if you think about it, g of 5 would equal -8 divided by, so we would have 5 plus 3 in the denominator plus 2, and that would give me -8 divided by 8 plus 2, so -1 plus 2 gives us that g of 5 equals 1. And we could plot that point and try to pick numbers that will help you divide by something simple. For example, if you substituted 1, you would be dividing by 4. -8 divided by 4 works really well. However, don't get discouraged if you have a fraction. Here are some great x values to choose from. And since we already did 5, I can write that in. That gives us 1, and then you go ahead and do the rest. Try them on your own, try without a calculator, try mentally, and then plot in those points. Pause the video here, and when you unpause, these are the values you should get, and then go ahead and plot these. Here are the points, and now connect them carefully. Again, you want to try to make a hyperbola, smooth curve. I did the first one with the video paused, and I will try to do the second one. As you can see, it's approaching the asymptotes but does not cross them. And if we wanted to give the end behavior, it would be that as x approaches -infinity, g of x approaches 2, which you can see happening here. And as x approaches +infinity, the g of x value would also approach 2. Option 2 is to graph by translating points. So if we thought of a simpler version of g of x being y equals negative 8 divided by x, we can make a table of values and substitute those values to get the y value, and that would give us the following. This would be the graph we would get. And recall from before that we said the h value was negative 3 and k was 2. So we could take those x and y values and we could say, well, to every x value, we're going to subtract 3. To every y value, we're going to add 2. And if you complete that table, you'll see that the points that we had there shifted 3 units to the left and 2 units up. There's my fancy animation. And just don't forget the arrows at the end of each branch.